Okay, so this lesson is all about logarithms. So we're going to talk about logarithmic functions. Okay, a logarithmic function is log, so this is an example I just put. Usually y equals or f of x equals your variable terms here. This is going to be a number. If there's no number there, so this has no number, then it's 10. That's called a common log. Okay? Now, how you get this is logarithms are inverses of exponentials. So this is true because if I make this into an exponential, this would be x equals a to the y. Okay, or yeah, the other way, a to the y equals x. So if this is my exponential, either way you want to put it, this is how it looks like as a logarithm. Okay, since we have natural bases, we also have natural logs. So a natural log is when, instead of having log with a base e, instead of doing that, this is when we use the natural log, which is ln of x. So instead of putting this, we substitute it in for the natural log. Okay. All right. Okay, now in order to be able to solve, or when we're going to do graphing, or as we move forward in this section and the next sections, you're going to have to be able to convert back and forth from logarithms to exponentials and from exponential to logs. So part of your assignment is just being able to convert to the other form. So the first two we're going to convert from logs to exponentials. The second two will be from exponentials to logs. And then I did one with a natural log and then one a natural base. Okay, so everything I'm doing is I'm looking at this equation, and it doesn't matter which one you use, this one or this one, okay, depending on what you want first. Okay, since these are written with the exponent first, I'll focus on what this one looks like. Okay, so if I want to write this as an exponential, I need a to the y. Well, a is your base, y is what it's equal to, so this would be 4 to the third equals, then I need my x is equal to 64. Okay, same thing on this one. I want my base to the y, so I would do 32 to the 2/5 equals 4. Okay, and I'm going to go ahead and skip to number 5, because number 5 is a natural log. So for the natural log, the base is e, so this would be e to the negative 0.693 dot dot dot. Okay, the reason why it's dot dot dot, it goes on forever. Okay, equals a half. Okay, and then the other direction where we do exponentials, write it as logs. So I want y equals, well y is the exponent, so this would be 3 equals log, my base is 5, and this is of 125. Okay, just like these exponents are in the superscript, this number is in the subscript, it's little. Okay, so this one would be -2 equals log 6 of 136. Okay, and then this last one, this would be, okay, so I want equal to. Okay, so I would have a log e. Now instead of doing a log e, we're going to do your natural log. Okay, so my exponent would be 3. So 3 equals, so instead of log e, this would be natural log 20.0855 ... Excuse me. Okay, then you're actually going to be able to evaluate. So we'll do one with the log and one with the natural log. So with the log it says x equals 4. So we're literally going to plug in 4 for x. Okay, since it's not equal to anything, we're going to make it equal to y. And we're going to solve for y. So this would be 16 to the y equals 4. Okay, if you think back to when you're in algebra 2, we need to have same basis. So 4 squared is 16, so this would be 4 to the 2y equals 4. And then I solve exponents. So this would be 2y equals 1, because that'd be my exponent on there. So this would be y equals 1/2. So you set it up like an exponential to solve it. Okay, when you're doing natural logs though, because we're just plugging this straight in here and, okay, so the log button on your calculator, you can only use if this number is 10. If that number is not 10, we have to make an exponential. For natural logs, we don't have to convert that because we already have a natural log button. So what you do is you do the natural log of 0.75, and then you would multiply that by 2. So the answer to this would be -0.575. Okay, we'll do more complicated equations later. These are going to be basic log equations that you're going to solve. Whenever you have a log on both sides, same log, which they will be, okay, and one log on both sides, which for this lesson there will be. We'll talk about what do you do when there's not. How you solve it is the logs cancel, and you solve what's left. So how would I solve this? Well, I would subtract 1, so x equals 3. Doesn't matter if it's a regular log or a natural log. If you get one on both sides, those cancel each other out. So I have x plus 2 equals 6. And then for this one I would subtract 2. So I have x equals 4. Okay, then the last part's graphing. Okay, so the first thing we're going to do is we're going to find the domain. You cannot take the log of a 0, and you also cannot take the log of anything that's negative. So if you want to find the domain, we're going to take whatever this log part is, whatever this x part is, and we're going to set that greater than 0 and solve, because we can't take log of 0 and we can't take log of negative. Okay, well this is already solved, so that means our domain is all reals greater than 0. Whatever number that is after you solve is also your vertical asymptote. Remember, vertical asymptotes, you need x equals your line. Okay, to find the x-intercept, we're going to put 0 in for y and solve for x. Okay, well if I put 0 in for y is the same thing as f of x. So that's what my equation would be. First thing I do, write it like an exponential. So just like we talked about in the first 6 problems I think we did, this as an exponential would be 4 to the y equals x. Well, if I want to find the x-intercept, I'm going to put 0 in for y. So 4 to the 0 be 1, so my x-intercept is 1. So you can either put it like that, or you can put it as a point. Okay, when you go to graph this, it says for my domain, I need numbers that are greater than 0. Okay, now domain are your x's. We're not going to plug it into the x's because that makes our life harder. We're going to plug numbers into the y. So we're going to use the same rules that we did yesterday with -2, -1, 0, 1, and 2. But this time, you're plugging them into your y values. Because if you do that, then this is just like how you solved yesterday. So like I would do 4 to the -2nd, which is 1/16. 4 to the -1st, 1/4. 4 to the 0, 1. 4 to the 1st, 4. 4 squared, 16. Okay, now they're going to look similar to, I'm not going to graph 16 too because that's way too big. Okay, if it says that all numbers have to be greater than 0, it means I can't cross this line. So I still have an asymptote. It's just like the graph is almost like turned sideways. So they're still curving, it's just like it's turned, instead of being up and down, now it's going to be like right or left. Okay, which makes sense because these are inverses of exponentials. Alright, let's do one more. We'll do a natural log. Okay, so for our domain, we take our x part, which is x minus 1. And we're going to set that greater than 0 to solve. So if I want to solve that, I would add 1. So my domain is all reals greater than 1, which means my vertical asymptote is x equals 1. Okay, if I want to graph this out, I need to write it like an exponential, so my base would be e, so this would be e to the y equals x minus 1. So this would be e to the y plus 1 equals x. So if I want to find my x-intercept, I'm going to put 0 in for y. So e to the 0 is 1, 1 plus 1 is 2. Okay, this is just still y up here. Now this hasn't been shifted to the right or to the left, so we're going to use these same numbers. You only change those numbers if the graph's been shifted by having something in the exponent. Okay, so if I put in -2, e to the -2nd, and then I'm going to add 1, this would be 1.14. Then I have e to the -1st, add 1, 1.37. E to the 0 is 1, plus 1 would be 2. If I plug in 1, e to the 1st, and then add 1 would be 3.72. And then e to the 2nd, plus 1 would be 8.39. I have 1.14, -2, 1.37, -1. Remember my third class was 1, so it can't cross this line right here. 2, 0, 3.72, 1, 8.392. 1, 2, 3, 4, 5, 6, 7, 8. So it would look like this. Okay, graphing logarithms, we did it one year I taught algebra 2, we didn't do another year I taught algebra 2, so I'm not exactly sure. I mean, we did a little bit both ways, but some with more depth than the others. So if you have questions on this, definitely make sure you ask me. Okay, this should get you all the way through your page 236, and you'll have 6 graphs. Some of them will be regular logs, some of them will be your natural logs.